Hello, this is the section 16.1 lesson on the topic of basic principles of probability. Now, chapter 15, we talked about statistics, and statistics and probability always go together, and students are often confused on the relationship between probability and statistics. So let's talk a little bit about that relationship. So in a statistical study, we'd like to know something about a large population. So our population might be a group of people, a group of animals, a group of candy, or whatever, some very large population. So in that study, we might want to know the mean of that population, like a mean height or a mean weight. Or maybe you want to know a proportion, like what proportion of that population of candies is blue or something like that. Well, in order to know the exact answer to those questions with 100% certainty, we'd have to get information from every single member of that population. So we'd have to go out and survey every single person, or look at every single candy, or do something like that. Well, that's very difficult, if not impossible to do. So instead, what we do is we get information from a sample. So we take a survey of a sample of people, or a survey or a sample of candies. Maybe from that sample we calculate a sample mean or a sample proportion, and that's relatively easy to do. And then we maybe create some graphs or do something like what we did in chapter 15, and that's generically referred to as descriptive statistics. And so then we take information from that sample and we use ideas from probability to make a generalization about our population. And that's what we generically refer to as inferential statistics. So chapter 15, we worked with our sample and calculated descriptive statistics, and then we're going to combine that with some probability to do some inferential statistics. Now in this class we're not going to get into any inferential statistics, but we should be aware of that relationship between statistics, descriptive statistics that we did in chapter 15, and probability, how we use probability with ideas from chapter 15 to make a conclusion about our large population. So let's start off with kind of an informal definition of probability. Probability is a measure of how likely something is to occur. So as an example, let's say we've got this spinner here with 3 equal size pieces, and we got our spinner there, and it spins and lands in one of those regions. And so the question is how likely is it that we get a blue? Or maybe that's a question we might ask. Well, that's a probability type question. Now, in more formal mathematical notation, we'll use this notation to indicate that question. We say P of blue or red, the probability of getting blue equals what number? So the question is, what's the value of that number? Well, before we get to calculating that number, let's talk about some definitions here. So first of all, an experiment is some activity in which the result is unknown until it's performed. Spinning a spinner is an experiment. Flipping a coin is an experiment. Rolling a die, that's an experiment. We don't know what's going to happen until we actually do it. An outcome is a result of an experiment. So if we land in blue, that's an outcome. If we land in white, that's another outcome. We roll a die, we get a 6, that's an outcome. Sample space is the set of all possible outcomes, and that set could be rather large or it could be rather small. Like when we spin our spinner, there's only 3 possible outcomes. An event is a collection of one or more outcomes. An event could consist of just one outcome, or it could be rather large and consist of several hundred outcomes. So now in terms that we just defined, let A be an event, and then generically P of A is a measure of how likely that event A is to occur. So we really describe probabilities in terms of probabilities of an event. And a probability can take on values between 1 and 0. Probability of 0 means that that event is impossible, meaning it'll never happen. A probability of 1 means that event is absolutely certain to occur. Probability 0.5 means there's a 50-50 chance of it happening, so it's just as likely to occur as to not occur. If the probability is greater than 0.5, we say the event is likely. If it's less than 0.5, we say the event is unlikely. And then one kind of magical number in probability and inferential statistics is 0.05. An event is considered to be unusual if its probability is less than 0.05. So if you ever take a statistics class, you'll see that number 0.05 come up a lot, and this is why. Now we're not going to see it here in this class, I just thought I'd mention it. So let's talk about two ways of calculating probabilities. The first approach is what we call a relative frequency approximation. And I stress the word there, approximation, because this approach here is not going to give us an exact theoretical number. It's only going to give us an approximation of the actual probability. And the basic idea here is simple. We perform the experiment several times. Each time is called a trial, and record the number of times the event occurred. So then the probability of our event is approximately equal to the number of times the event occurred divided by the number of trials. So the arithmetic there is very simple. We just divide the number of times the event occurred divided by the number of trials, and we're all done. But remember that this gives us at best an approximation. And this approximation that we get is called the empirical, or also called the experimental probability. So let's do a quick example of how we could do this calculation. Let's suppose that we spin this spinner 100 times and we get blue 35 times. So then our probability of blue is approximately 35 divided by 100, which is 30.35, or sometimes we report probabilities as percentages, 35%. So the probability of blue is approximately 35%. And again, remember, this is at best an approximation. It's an approximation because if we were to spin it another 100 times, we might get blue a different number of times, and that would get us a different approximation of blue. Now in our activities in class, we're going to really illustrate this idea that this approach gives us at best an approximation of the actual probability. So that was rule 1, an approximation. Let's talk about a little more theoretical approach that will get us an exact theoretical probability. We'll call this the theoretical approach, and this only applies if all of the outcomes are equally likely. If one outcome is any more or less likely than any other, then this approach isn't going to work. And so here we calculate the probability of A by dividing the number of ways that the event can occur divided by the total number of possible outcomes. And this will give us an exact theoretical probability. And so this approach is also called the theoretical probability, the actual probability, or the classical approach. Just goes by different names. So let's apply this to our example of the spinner, and let's calculate the exact theoretical probability of getting a blue. Now notice that our pieces on our spinner here are all the same size, so that means that everything is equally likely. So that means we can apply rule 2. We have 3 possible outcomes, blue, red, and white, and one of those is blue. So the theoretical probability is just 1/3. That's it. Let's do another simple example. We might ask, what's the probability of getting a non-white outcome? Now non-white means either blue or red, and so we see that there's 2 outcomes that constitute that event, and there's 3 possible outcomes, so our exact theoretical probability is 2/3. So that's all there is to using rule 2. Just count outcomes, divide, and we're all done. So we calculated probability of blue equals 1/3. Let's talk about what this means and what it does not mean. So first of all, it does not mean that exactly 1 out of every 3 trials will yield blue. So it doesn't mean that if we spin the spinner 3 times, we're going to get blue exactly once. No. We might get blue exactly once. We might get 3 times. We might get it 0 times. We might get it 2 times. Doesn't tell us exactly what will happen on 3 trials. Nor does it mean that exactly 33% of our trials will yield blue. We'll probably get somewhere around 33%, but it could be a little bit higher, a little bit lower. And we're going to illustrate these ideas in the in-class activities. Now let's talk about what it does mean. It means that if we were to do many trials, meaning several hundred or thousand trials, and if we divide the number of times we get blue divided by the number of trials, that should be pretty close to 1/3 or 33%. So if we were to do this a whole bunch of times, about 33% of the time we should get blue. This idea is sometimes referred to as the law of large numbers. There, the large numbers refers to this idea of doing many trials, many several hundred or several thousand trials. So in general, a probability of blue equals 1/3 does not tell us what will happen on a single trial. If we spin the spinner once, we're either going to get blue or something else. That's all we can say for certain. This probability does not tell us what will happen on a single spin. However, it does tell us what will happen on average after many trials. And the book refers to this as in the ideal. So whenever you see that word ideal in the book, just think after many, many trials. So here's a simple sentence to kind of remember, that a probability is an average in the long run. It will tell us what will happen on average after a whole bunch of trials. It doesn't tell us what will happen in any one individual trial, but it will tell us what will happen on average in the long run, at least approximately. And we're going to really illustrate these ideas in the activities in class. So that's it for this lesson. Your assignment is to read section 16.1 from the textbook.